Hi, this is just a real quick introduction to water resource basics, I guess you could say. The water cycle, for what purposes do we use water? Just a really quick introduction. I wanted to review very quickly the definition of a resource. I think most of you are already comfortable with that, but just in case. So resources are anything that we need, not just to support our life, but also our lifestyle. So we need water and food to survive, but we need energy to support our lifestyle, really, or energy resources like electricity. We need those to support our lifestyle. Resources can be renewable or non-renewable. Again, most of you are comfortable with those terms, but renewable are resources that are replenished. So water is generally considered a renewable resource because through the water cycle, it is replenished. Non-renewable resources are resources that there's just a limited amount, and once they're gone, they're gone. Sometimes they're replenished very slowly, like coal, oil, natural gas, that in a human time frame, they may as well be finite. We'll talk about it in another video. Some scientists consider groundwater to be non-renewable because we're using it faster than it can be replenished. So just a couple terms. Again, I think you're familiar with them, but thought a review was good. The water cycle. This is one, I think, gosh, in elementary school, you learn the water cycle, but it is listed in the College Board AP Environmental Science, I guess, outline, so I better say something. So the water cycle, just got a quick little review here. So water is continually cycled from surface water to the atmosphere and back again. So there's water in a river, it can evaporate and end up back in the atmosphere, it can come back as rain, end up in the soil. So it's constantly cycled. And that kind of gets back to that law of conservation of matter, that matter is not created nor destroyed, it's just in different forms in different places in the atmosphere or in earth or in surface water. In the water cycle, it is only what we call phase changes. It's always H2O. There's never any chemical reactions. So in the carbon cycle, there are chemical reactions. Carbon can be in carbon dioxide, but then it can go through be involved in photosynthesis and the carbon can end up in glucose. Those are chemical reactions. But in the water cycle, it's just phase changes. So I put this picture here to remind you, right? Ice, and if you look, it's just H2O, right? You've got a hydrogen, and an oxygen, and they're bonded together. You can see the little stick things there, right? So it's two H's and an O, H2O. If it's water, which is a liquid, same deal. You've got hydrogen, and oxygen. Again, H2O. And then obviously when it's evaporated, H2O. So it's always the same chemical makeup. It's just in ice, the water molecules have formed connections with each other. In water, there's a little bit less of those connections, and in steam, there are none of those connections. They're all moving about. So just phase changes. All right, this is a very quick little animated thing I actually got from another website. So the sun hits surface water, like say a lake, and when it absorbs or takes on a certain amount of heat energy, right, some of that water is going to evaporate and it rises in the atmosphere. It's more energized. It's bouncing around. They're bouncing off each other. And they're more spread apart, I guess, for lack of a better word, less dense. And they rise in the atmosphere. As they rise in the atmosphere, it's cooler. They start to cool off and lose some of that heat energy. And so they start to move a little bit less, get a little bit closer together, and we call that condensation. And usually they'll stick, or I'll probably say always, but think about a glass of water, like ice water, and you let it sit for a while and you get water droplets on the outside of the glass. Those water droplets are actually from the air around the glass. They've just gotten close to the glass, cooled off, and then they stick to it. So for condensation to occur, the water droplets need to stick to something. Usually they'll stick to dust particles in the atmosphere, and they want to create clouds. So again, evaporation, the water molecules take on heat energy, they rise in the atmosphere. When they cool off, they slow down, stop bouncing off each other so much, get closer together, stick to dust particles in the atmosphere to make clouds. And then if conditions are right, there's a lot more to this that we don't get into, but if the pressure's right and the temperature's right and things are just right, you will get precipitation, and that could be rain, it could be snow, hail, sleet, but basically it's that water coming back down to earth, right? Coming back down to earth. And it would end up, in this picture, it would end up in surface water, maybe back in a river or a lake. But it could also hit the land, run off the land into a stream. It could also hit the land and sink down into groundwater. At this point, it's come full circle back. All right. This is the picture from your book. It's a little more elaborate if you are interested. I think the main difference is this one shows that when the precipitation hits the earth, it could hit the earth and run off, say down into a lake like that, or it could drop right into the lake directly. And then it also shows the precipitation could infiltrate the ground and end up in something called an aquifer that I have in another video. So I did have two more videos. One is about groundwater, one is about surface water, because precipitation, as I said, could infiltrate the ground and end up in groundwater in something we call an aquifer. So I have a video about that. Or it doesn't sink into the ground, but instead runs off of the land into what we call surface water, like rivers and lakes. Lastly here, where is Earth's water? So we always talk about, oh, there's so much water on the planet, right? But the fact is only a small fraction of it is actually liquid fresh water that's usable or available to us. I just found a couple pie charts I thought were pretty basic. If you look, most of the water on Earth is salt water, right? 97.5%. Only this little fraction, 2.5%, is fresh water. And that's the water that's easily, I don't even use the word easily, but that is accessible to us as the fresh water. But then if I take that fraction of fresh water, 2.5%, of that, a big chunk of it's frozen. It's in ice, it's in snowy mountainous regions. So that's not easily available to us, right? So of that 2.5% of the fresh water that is available to us, only a fraction of that is what we're going to use. Groundwater and water from lakes and rivers. So I wanted to point that out just because we think of the planet having so much water, but a lot of it is just not easily usable or available to us. It's either salt water, which is very difficult and takes a lot of energy to desalinate, and then of the fresh water that is on the earth, a lot of it's in glaciers, it's frozen, not easily obtainable. So we've just got this little fraction that really is accessible. How do we use that water, that fresh water? These are the three biggies. Domestic would be in your home. Oops, not the best line there. Would be in your home to take a shower, to drink, to cook, wash your car, all those things you do at home. Agriculture, irrigation, and I have a video on irrigation. So that'd be to irrigate our crops. And then industrial, pictured here, it's like a wastewater treatment plant. So this could be a factory. There could be factories that need water. Industrial processes like wastewater treatment require water. Mining requires water to mine minerals. A big one would be the production of electricity. And down the road next week, I have a video about that. But in a power plant, you need to cool down the system, just to keep it simple. And to do that, you need water. You need water. So energy production or electricity, I guess we should say production or generation, requires a lot of water. So domestic, using water in your home. Agriculture, water crops. I guess even feed animals in a feedlot or handle the business of a feedlot. And then industrial would be factories, wastewater treatment plants, mining, the production of electricity. So worldwide, most water is used for irrigation. This is worldwide. Most water is used for irrigation, followed by industry, and then domestic would be use in the home. Right? And then I found this, I thought was kind of interesting. It was by continent. I thought this is a little more telling. If you look at North America, which is us and Canada, right, and Europe, you look at those two, orange is industrial use. And if you look, there's a lot of water used for industrial use compared to, say, like the continent of Africa, right? Much more water is used for agriculture. The blue is agriculture, and just a tiny little fraction for industrial use. If you think about that, it makes sense. North America is home to highly developed countries. Europe's home to highly developed countries, countries that are very industrialized. So more of their water is going to industrial purposes, right? Or if you think of countries on the continent of Africa, they're often less developed. They're still dependent, most of the people in those countries are dependent on agriculture and subsistence agriculture, growing food to feed themselves. So that was kind of interesting. Well, worldwide, most water is used for agriculture and irrigation. You kind of break it down by highly developed versus less developed countries. It's the less developed countries that are really using that water for agriculture. And I just thought, well, let's bring in a little California, see what we're up to. And again, you can see we're highly developed. So we've got our industry, right? We've got our agriculture, and we actually use quite a bit for residential, for home uses. If you look at that comparatively to worldwide, where most of it's used for agriculture, right? Kind of right on par with the worldwide, for close with industry, but we use a bit more for residential for sure. I don't know if this is that exciting, but I wanted to bring this in for California, this idea of environment. So again, we use water in urban areas for home use, and that could also include industry, like industry in urban areas. We use water for agriculture, but this one, the environment. So that's water that we let go out into rivers. We let go out into a lake. Generally, it's rivers, but this water that we leave for the environment. So I thought that was important to note. So if you look at, here we've got Sacramento, there's a little fraction for urban people, you know, in their homes and industry. And there's definitely some agriculture in Sacramento area. But look at environment. So this is water that they need to make sure is in the Sacramento River, that they don't mess with, that they make sure is there for the Sacramento River and the Delta and all of that. The San Francisco Bay is kind of interesting. There's very little to no, right? Agriculture. It's just really urban uses. Well, that was kind of interesting. Also, the South Coast was kind of interesting. They're using a lot more for urban. They're not as concerned about water in the environmental setting. All right. Well, be good. Again, check out my playlist. It's water resources and irrigation. Lots of videos in there, and have a great day.